Bien le bonjour tout le monde. Je vais faire ma présentation en anglais, mais n'hésitez pas à me poser des questions dans les deux langues, ça va faire plaisir. Hi everyone, welcome to this presentation. I'm bilingual, so if you need to ask any question either in French or English, feel free to do so at any time during the presentation. I'm going to present to you the hardship of going through social media analysis in the context of a company trying to do so, especially a startup. All right, so who am I and why do I say actually matter? It's more about the experience that I have more than the formation that I received at first when I went to school. These are all the languages or tools that are going to be touched during the presentation that I learned or used during the context of this project and all the stuff that I went through on it. All right, so this is the general overview of what we're going to go through during this presentation. So we're going to review the data access and all the stuff that relates to access to any API or aggregation of any kinds. Then we're going to see about processing these data and normalizing it. And then we're going to have a look at how to analyze it and deal with the backend process required to aggregate those data, make something useful out of it. And then we're going to have a look at the UI display that we can make out of the analytics that we have processed before, and what kind of data analysis we can run on them and make that useful to people who want to have a look at it without having to read the entire context of the web. And then I'm going to finish with some AI usage pattern that I've seen in that field and expose the advantages and some limitations on it. All of this is going to be a general oversight of all of those things. Feel free to ask any questions about the specifics of it as the presentation go. All right, for data access, the complicated point about that is mostly the diversity of the data that you can get, the different sources and the conditions that you have to respect to get the data from these different sources. For example, like Twitter, you have a different format than Webos that gives you some news. There's also Twingly, which gives you blogs, and all of them have different terms of services, limitations that you have to respect. Otherwise, they restrict your access. And all of that is actually pretty good, like Facebook that used to give public content and at some point decided that it was to protect their user privacy to remove those access. Also like some other provider like DataSift, which which aggregates data from other sources and give access to it, were also forced to change according to all the latest privacy policy changes in the last decade. So all of that has really big impact on when you're trying to develop a software that actually uses those, since you need to keep up in some way. And in the context of a startup, if you are a low amount of people working on these projects, it gets very tedious to keep track of all of that. Just to give you some example, I have here like an extract of what a tweet looks like, specifically, like the format of it, and an extract of the Twitter policy and all the requirements. They give you links throughout all the different policies that there's out there that you also need to be familiar with and respect. And it's about like, it's a big part of legal concern and like all legal texts that you need to be aware of. It's more complicated since they actually change version from time to time, sometimes multiple times a year, and you need to keep up with all of that and adapt your software. And it takes a considerable amount of time to maintain all of that. Here's some example from webos.io, which give you some blogs. You can see here an extract of the content you can get, the format with it, and you see it's completely different from Twitter, right? And you can see on the right an example of how it looks like when you try to visualize it. So now that you figure out a way to get the data, you somehow connect to their API, get the data out of it, do searches using their API. Now you need to think about how you're going to store that efficiently to be able to analyze it. So you're talking about figuring out the common fields, or stuff that you can translate to, like the text of your of the records, the date associated with it, the author, and sometimes you have to deal with more platform-specific fields like retweet, extracted entities. You could have relationship in between some stuff. All of that you can either take only the common fields and ignore the rest, or take advantage of those extra fields for that specific source. Although it comes with a problem that we'll see later about how to display that. Once you figure that out, you need to figure out like how to store that on disk or using databases like MySQL, Postgres, potentially Aurora from Amazon, or NoSQL databases like Mongo. Each one of them comes with their own restrictions and limitations and advantages. So, for example, you can store any document that comes from any kind of API using Mongo, but like you won't have any unified template to analyze all of those records using the same code. So it's going to be a little bit more complicated to down the road to deal with all these analytics. On the other hand, it makes the storage a little bit more complicated since you don't want to lose anything about the original records. We have decided to go with MySQL on our side and make it customized to our use. We discovered that doing that leads to some other issues. Depending on the scale at which you're grabbing data, it could come with a problem. It won't be a problem if you go with like 5,000 or 30,000 tweets, but if you go with like 500,000 tweets or more, it begins to be a problem of speed of ingestion. So saving that to disk could be a problem. It could become slow. You can have other, it could affect other systems. It could make the analysis derived from those databases also being more slow as the ingestion takes over. And also there's other I/O issues, not necessarily database on disk, but when you get records from those different sources, sometimes they contain links, and those links are shortened to make it, when you try to display them, to be easier to read from the user. And you need to unshorten that to have the full URL, get the title, get something meaningful for your analysis. And that could cause other problems, like you could use up all your bandwidth for your servers, and that could prevent your application to run as a whole. So you need to get those little problems sorted out down the way by using some bandwidth limiter, like Squid or something like that. Next, we talk about the analysis and the backend process, the backend access out of that. In that section, we talk about how to perform analysis, how to deal with filtering and recovering, and how to add features easily to that backend access that you'll be building. Sometimes it could be more complicated to add more to it depending on how it's built. All right, so for the analysis, the backend service that you probably will build is going to you need to select a format so that you can have some consistent way to get the data out of your system. So of course, you'll get the data inside a database, and then you need to write up the queries to get the aggregation out of it. And you need to translate that in something that what you'll build to display that to the user can read easily. So you need to do that, either JSON, XML, or any other format. Also, you'll need to figure out, like for some analysis, especially on large data set, it takes a lot of time to process those information. You need to see about how you're going to make that processing either synchronous or asynchronous. If you're tracking progress, send the progress to your front end so the user can have a feel of how it's going, making sure that there's no bug with the software, or the user don't feel like it's just being hanged there and nothing happens. So a feel of making sure that something happens really make the user more confident about the stability of the platform. And then you'll need to see about caching, because those analysis rely on some data which could be expensive to reanalyze over and over, especially if there's no change in the analysis. So you want to save that somewhere, probably using a reverse proxy or caching the data on the report itself on disk. There's multiple strategies you can use there, either by using memcache or any of the likes. Once you figured that out, you still need to figure out about how to filter the data to get a relevant subset of what is being analyzed. So to give you a more concrete example on that, you would say you would capture anything about COVID, but that would give you a very huge data set of the various point of views of everyone about, like, either is it true, is it false, the different analysis from the scientists, or like the mask problematic that people bring up all constantly. And this could be overwhelming to have a look at and probably confusing. You'll get a bunch of analytics which doesn't reveal you any particular information. But you want to analyze a subset of that and say, oh, what about the mask? What do people say about the mask, right? So you could filter on mask and get a subset out of that. And all the analysis could be derived from that subset and make it easier to understand the context of that subtopic. Well, this is how you do it. One way of doing it is to enable the user platform to specify a filter description, which tell him like which keyword to use, which keyword to not use, and make that filter as complex as the user desire. Although we figured out that by giving the possibility to the user to do everything like that comes with some complications, especially when the user is not necessarily super tech savvy. We figured that there's a problem with the search operator that they use, the and, the or the priorities, the parentheses. People tend to confuse the and the or, and it comes with some other problems of like explaining Boolean logic to people who are not used to use those in a programming context. So there might be some graphical way to display that so that the user get it more easy. Then we talk about how to easily add features. So this is some example we have built on our side about an internal API auto-generated documentation. So the documentation is merged with the code. So when we change something around the feature, we add a documentation with it. So it's really easy to maintain. And since the documentation is generated by itself, it's really easy to follow and like read about it as you develop it. As well, we have included not only the documentation about those calls, but a mean to test it directly from that webpage, which is really useful. Although, taking consideration that all of that was created way before tools that now exist to do that automatically. So it might not look as good, but it worked pretty good back then. All right. Now we have the filtering. We have a way to get the data out of it. We need to figure out a way to display that properly. So building reports that makes it easy for people to understand what is going on and be able to dive in it and analyze subsets of those discussions. So these are examples of basic reports you can see in some software that does that, giving you up the list of top hashtags, top words, a basic timeline of like how many posts at which hour and so on. And you can click on any of those to get the related tweets or filter on either hashtag, words, or a set of time. That seems really basic filtering. Then some other thing we can do with it is figure, like in the context of Twitter, people tend to mention other people a lot of the time. So how do you figure out like who talks to who in a meaningful way than just one step iteration and say, oh, that guy seems to be like a big talker? Well, in this case, you can see the list, a map, a network map that shows like who talks to who and in which proportion. So you can see that the arrow points in the direction of the direction from the people that talks and to the people that is being talked to. And the colors could be used to identify who talks more, and the blue people, and so the other color could be used to figure out who is more a receiver of those discussions. And this is really useful to manually identify either influencers or bot, because there are specific behaviors around that. If you tend to see like clusters of like one or two people talking to like 15 people, you guess that those are actually bots, and they probably are the same bots over contacting the same people, or derived from in any ways. Another thing we have done that is also quite useful but complicated to use is what we call the Dexcom Map. So from the analysis that we have run before, we extracted words from the tweets, and then we figure out which words are related to which other word in the same tweet, and we make a map out of that. And then it shows the proportion of tweets of words used, and how many tweets use that word. So that's what you see as the size of the node, for example. And the link length and strength is defined by the strength of the relationship. So the more closely or accurately these words are used together, the closer they are together. And you see that naturally formed clusters of discussion, basically subtopics around some issues. But like this map has its own problem. It's really quite hard to read. It's more like so after a while you go by feeling or something. The expertise takes some kind of time to show up. We estimated it takes about 2 or 3 months for people to be able to use that map very precisely. But when you get around that, that gives you huge reward. But we're still trying to figure out ways to show these in a relevant fashion that doesn't lose any kind of information, but still display that to the global information to the user and make it easily understandable. So this is an example of like what could have been done better and some problems around it. All right, so now let me go about some AI usage patterns. One way we actually use it is to summarize the content of the discussion. And we use that mostly going through sample size. So we batch the data, and then we figure out the most common summary that could define that batch using an algorithm named Jensen. And we could also, and then we get that to get the most relevant representative of those things, and then we try to get from the most representative, get the most different from all of them, to get an interesting sample of the summaries that you can have there. So that approach we try to get you the most interesting topics that you may not necessarily have seen without reading all the tweets. So I've been asked like if I had any example of usage of the Dexcom Map that I showed before that makes some sense. One example that I went with at some point was there was a Grammy with Lady Gaga having her meat robe. That was a super kind of big event. So I actually didn't look at the Grammys at that time. So I wanted to know what's going on without looking I didn't look at Facebook or anything since. So I had virtually no idea of what happened. So I recovered the 5,000 tweets on that, and I tried to analyze what's going on in that data set. And I figured there was a cluster that talks about there was a node for me, there was another one for Ro, but there was Lady Gaga related to all of that, and we could see it very clearly. We could see as well, I think there was something with her doing a nude Photoshop and a nude photo shoot for a magazine for a really interesting cause at the time. And there was another problem with another guy during the Grammy, and all of that was showing in the map. You could see it clearly, the cluster, different clusters, barely related between each other with the Grammy in the middle. That was super interesting. It took me 5 minutes to figure out what's going on without reading any of the tweets. That was really cool. All right, and then if I go with the one last, the entity recognition. So what we do here is we extract entities out of Wikipedia, and we use that as examples to train models so that they can identify those entity from the tweets using the context of the tweet, so that we have the tweet text, and we try to figure out which article is more similar to in terms of words and meaning used with the entity that we have discovered in that tweet. So the more similar the content to the article and the entity, then the more likely that this entity is actually related in the tweet. And this is a summary of the extracted entities from different tweets. And that gives you a clue of what is being talked of, or places, or like facilities. Any kind of entity that is in Wikipedia could be extracted that way. But these comes like with limitations. There was another presenter earlier today, and he actually talked about the AI way better than I would. But like some key points was where, and I was going to talk about that as well, was the limitation of AI. And AI at the current moment, using machine learning and deep learning, mostly can more reproduce patterns that we have instructed it to figure out. So in that context specifically, what it means is that if some new entity were to be created on Twitter by or begin to gain in importance, and it's not found in any of the sources that we have used to train our model, like in Wikipedia, that entity wouldn't be found in any way using our algorithm. So it would be totally missed. And there's no way we can figure it out at this level yet. So the creation of content to be figured out by NLP stuff is still not yet there. But we're still getting very interesting ways of categorizing the data, and it makes it really easier to be aware of the context of whatever you're analyzing, be it your brand, your political situation, any kind of information or context around some political figures, companies, name it. Everything you can analyze using those approaches. All right, so that's it for me. Thanks for watching. If you have any questions, I have still like 8 minutes left, so feel free to ask any questions. I'll be on standby meanwhile, and potentially decide to add more stuff to it as it goes. Thanks. By the way, I didn't talk too much about like the database level problems that you can go through. Maybe go more in depth on that. So one of the big problems you could have, yes, it's the scaling of the ingestion of data inside your database, but there's way to make that easier. Like in MySQL, there's multiple ways you can use to insert data inside a database, be it single row inserts, or we can have inserts and batches, but we can also go with load in files. So all of them have different speed of ingestion. It depends on the context of how you actually process the data, but it's always recommended to ingest that in batch to make it really faster. And we have seen increase of speed from the singular insert to a batch, let's say of 50 or 1,000 records, that goes about like 20 times faster. And when we use load in file, we figured that it was about between 500 and 1,000 times faster, I think. And that was a huge importance. And that all of that was using MySQL 5.6, which is pretty old right now. And the numbers are better with MySQL 8. All right. I'm being asked, confidentialité, vie privée, quelles sont les limites de domaine? Considérant le contexte des médias sociaux et puis des conséquences que ça a là-dessus, il y a beaucoup de compagnies qui ont décidé de changer leur approche, notamment Twitter, avec les changements de privacy policies et autres, dans le but de protéger davantage les utilisateurs. Ils ont vraiment changé leur fusil d'épaule avec le temps en disant, en fait, en prenant action et en faisant certain que les gens qui utilisent leur API puissent pas s'en servir, par exemple, pour identifier les personnes individuellement, s'en servir pour faire du targeting, si on veut. Par exemple, un gouvernement qui voudrait trouver les gens qui se rebellent contre lui pourrait potentiellement se servir d'une plateforme pour identifier les gens qui ont un discours comme ceux-là, puis après, c'est de trouver une façon de les retracer pour pouvoir les arrêter. J'imagine à quel point ça pourrait comme facilement, en tout cas, être bad, là. Fait que, ouais, c'est ça. Fait en changeant ça, ils ont clairement statué qu'ils voulaient protéger leurs utilisateurs. Puis ben ça, c'est vraiment une bonne chose. C'est sûr que ça vient au détriment du fait que les gens qui peuvent pas vraiment utiliser leur API nécessairement pour aller chercher certains types d'analyses. Mais je pense qu'éventuellement, ils vont sortir, ils vont travailler sur des moyens de faire des analyses, des données peut-être plus de façon anonymisée, en permettant de sortir les données en dehors de leur contexte, qui pourraient par exemple faire du brand analysis. Il y avait entre autres Facebook qui avait travaillé là-dessus en faisant... il avait sorti Pylon. D'ailleurs, Facebook a été un peu plus rapide, si je ne me trompe pas, que Twitter à ce niveau-là. Il y avait justement coupé court avec Datasif, puis tous les accès à API avaient été arrêtés pas longtemps avant. Puis eux autres, ce qu'ils font, c'est qu'ils ont une plateforme qui permet de déterminer c'est quoi les critères de recherche, puis c'est eux qui sont responsables de vous donner les analyses. Comme ça, les données ne sortent pas de Facebook, puis tu peux pas y avoir accès en tant que compagnie en général. Bon, c'est sûr que là, je parle pas de leurs accords privés, mais... on me demande par rapport, c'est quoi le coût des accès aux données? Ça dépend. Si tu utilises l'API de Twitter public, les données sont gratuites, mais ça vient avec une certaine limitation au nombre de données que tu peux récupérer par heure, le nombre de calls que tu peux faire. Sinon, si tu utilises... Puis aussi, tu peux pas non plus aller chercher l'information dans le passé beaucoup. Twitter permet d'aller chercher 10 jours. D'autres sources de données ne permettent pas d'aller plus loin de 30 jours. Ça dépend beaucoup. Tandis qu'avec Idnip, qui est leur plateforme payante d'obtenir les données, tu peux aller chercher les données jusqu'à la création de Twitter, mais tu payes quand même cher. On parle de quelques dollars par jour de recherche, puis après ça, on parle d'un frais de licence par enregistrement. C'est sûr que si tu récupères, mettons, 50 000 tweets, ça va te coûter peut-être 150, 200 pièces, mais si tu parles de genre 1 million de tweets, ça commence à devenir un passé si bien avant de se lancer là-dedans. Puis après ça, chacune des autres plateformes d'agrégation ont leur propre façon de faire pour charger. Des fois, ils vont te charger simplement pour l'accès, peu importe le nombre de calls que tu fais. Il y en a d'autres qui vont te charger par nombre de recherches que tu fais. Il y en a qui vont te donner un nombre de calls spécifiques par mois. Après ça, il y a la question de la complexité des requêtes que tu fais pour obtenir des données plus pointues ou pas. Tout ça vient avec un certain coût, bien sûr. Fait que ça dépend vraiment du provider à ce niveau-là. Après ça, on me pose la question, notre cerveau est-il conçu pour recevoir autant d'informations? En général, bon, je ne suis pas un expert dans la matière, mais je pense que notre cerveau n'est pas fait pour analyser facilement comme 1 million de tweets. T'sais, ça fait comme pas de sens d'accumuler autant d'informations. Puis je pense que tu vas perdre un peu le fil de ce qui se passe. On est particulièrement meilleur, par contre, pour avoir une vue d'ensemble, comprendre le contexte global. Par contre, ces outils-là sont utilisés pour faire les deux. Tu peux soit aller chercher une vue globale très facilement, puis après ça, tu peux aller chercher des anomalies si tu veux. Il y a encore des analyses, en fait, des features qui se font rajouter dans les divers softwares, notamment là-dessus. On travaille encore là-dessus pour trouver les anomalies du genre. C'est normal qu'il y ait 10 tweets par jour à midi parce que les gens prennent leur pause. Mais qu'est-ce qui se passe quand il y en a 50? Ou qu'est-ce qui se passe quand il y a un tweet tout seul, mais à 2 heures de l'après-midi? Ces genres de choses-là peuvent être détectées et après ça, ça peut être utilisé pour trouver les choses qui sont peut-être plus importantes à avoir l'œil dessus. Comme par exemple, quand tu veux analyser le contexte d'une brand, ben, ces genres d'analyses-là vont être extrêmement importantes pour la compagnie parce que c'est ces anomalies-là qui leur permettent de savoir quel genre d'ajustement il faut qu'ils fassent. Comme par exemple, s'ils savent que leur auditoire est présent particulièrement en ligne à une telle heure versus une autre, ils peuvent faire sûr que leur publicité sorte à ces heures-là. Tu sais. Mais ça fait énormément d'informations, c'est pour ça que ça prend un logiciel pour s'en occuper. C'est impossible autrement. Là. Tu peux pas lire 1 million de tweets. Jamais. Alright. Il me reste à peu près 40 secondes. Je vous remercie énormément d'avoir assisté à cette présentation-là. Si jamais vous avez d'autres questions, je vous prie de me contacter. Je vais laisser ma slide 2 secondes pour si jamais vous avez besoin de me contacter sur LinkedIn ou sur Twitter. Ça va me faire plaisir que vous puissiez me contacter et qu'on puisse discuter de choses et d'autres relatives à la programmation ou à ce genre de fonctionnalités-là, les médias sociaux, leur analyse. C'était extrêmement de surface. Selon moi en tout cas, et j'espère que vous avez apprécié. N'hésitez pas à me poser des questions, à revenir là-dessus ou partager la vidéo. Et encore, merci énormément à Campus Party de m'avoir permis de faire cette présentation-là. Donc, merci.